In system design, how do you architect a high traffic API that handles 1 million of requests per day with reliability and load latency? For handling high traffic, we have to design a high level architecture like clients. For the clients, we have to use the like web mobile third party integration. Edge, like we have to use the CDN for the static assets, caching of catchable API responses, WAF, global load balancers, like cloud load balancers, we have to utilize. API gateway we have to utilize for authentication, routing, rate limiting, request shaping, API composition for client specific responses. Service tier we have to use for the stateless microservices or small service groups behind internal load balancers. Each service run in the containers like Kubernetes, ECS, and is auto scaled as well. Cache layer like Redis cluster for the read through, write through pattern, tokens and session store, short lived caches for the list endpoints. Data tier like primary store for the transaction data, relational database with read replicas, PostgreSQL, Aura, Cloud SQL, DynamoDB, secondary store for high velocity flexible schema data like MongoDB document store basically MongoDB or DynamoDB needed. Search index like Elasticsearch, OpenSearch for the full text and complex filtering techniques. Async layer, message broker like Kafka, RabbitMQ, SQS plus SNS, simple queue service, simple notification service for the background jobs and decoupling. We have to use the workers, background workers for the heavy jobs, notifications, indexing, analytics. Observability, we have to use the metrics, CloudWatch, tracing, or open telemetry, logs, ELK or Loki, alerting and dashboards, Grafana. For the CI/CD process, we have to use the GitOps or pipeline for the lint, test, and canary deploys, rollbacks, feature flags. Operation like multi-agent deployment, automated backups, and chaos test. The request flow will be concrete. Basically, client will be CDN. Client will be CDN, and if response catchable, if catchy miss, global LB or API gateway. API gateway performs auth, rate limit, request validation, then routes to the service. And the service checks the Redis cache for the hot data. If the cache miss, query DB for or search cluster. For non-blocking work, publish events to message broker and return quickly. Responses are logged, traced, and matrices emitted. Key patterns and components to ensure low latency and reliability. For this, basically, we have to edge catching and serial. Cache static assets and any catchable API responses at the edge to save off latency and reduce origin head. Read through, write through Redis layer to prevent DB hotspots for frequently requested keys. API gateway, which is the central place for the authentication, throttling, logging, response aggregation, and also offloads cross-cutting concerns from services. Auto scaling plus health check, horizontal scaling for the stateless services, and scale on request latency or queue length, not just CPU. Connection pooling, DB connection pooling at application level or via sidecar to avoid connection storms. Sidecars basically these are the side helpers. Read replicas and query routing. Push read heavy queries to replicas or keep critical writes to the primary. Partitioning or sharding technique is available for very large data set, shard by users or tenant to limit single shard hotness. Asynchronous design is available. Slow operation asynchronous use queues to smoothing burst bulk batch workers for a heavy processing task. Circuit breakers and retries to prevent cascading failures and implement exponential backup. Bulkhead isolation to isolate expensive work in separate worker pools or services. So overloaded path does not affect others. Idempotency for the retired request. Ensure safe idempotent operations or dedupe with request IDs. Back pressure, graceful degradation. Queue length checks reject heavy endpoints. Early return, lightweight feedback responses if needed. For the data scale, consistency, and scaling, we use the ACID relation database for the core transaction data, where consistency matters. Use read replicas and partitioning. Use NoSQL for the high throughput, flexible schema items and catch it aggressively. Use Elasticsearch or OpenSearch for the search and complex filter and update index asynchronously. Designed for eventual consistency where strict consistency is not needed. Otherwise, use two-phase flows or saga pattern for multi-services updates. For reliability and SLOs, uh, like we have to define the SLOs. P95 latency is less than 200 millisecond. Availability 99.95%. So we have to translate SLO to enter budget and scaling alerting rules. Multiple agent deployments and automated fill over for the database. Use controlled failover testing and run books for incident response. Canary and blue-green deployments to reduce deployment risk. For the observability, and ops, we have to trace the request flows across services to find latency hotspots is available there. Matrices like RPS, latency percentiles, error rates, Q depth, DB matrices, logging. We have to check the logging also, structured log with request IDs, alerts like triggered alerts for P1, P2, P3, or use paging only for the P1 runbooks and post incident reviews. For the security and abuse protection, we use the authentication token based authentication like GWT token based JSON Web Token. It's a full form with the short TTL we can say and a refresh flow. Short lived sessions in the Redis can be stored. WAF rate limiting per API key per IP address and bot protection. We have to sanitize, we have to validate input and least privilege access for the services for to the database. Testing and validation. For the testing and validation, we have to use the load testing, K6 Gatling or G meter for real traffic shape. I prefer mostly J meter. Validate to validate auto scaling triggers. Chaos engineering inject failures for the dependencies and ensure graceful degradation. Integration E2E test in the CI. So I want to give an example for the concrete stacks. Like we have to use the CDN edge called CloudFront Fastify. For the API gateway, we have to use the Nginx library or AWS API gateway. For the containers, we have to use the Kubernetes EKS or AWS ECS frag rate. For the caching, Redis cache is preferred mostly for the clustered. DB database, we prefer PostgreSQL primary and read replicas or Aura as well. Aurora as well. For the search, we have to implement the OpenSearch or Elasticsearch. For the queue, we have to use the Kafka for the high throughput or SQS for the managed queue. For the observability, we use the telemetry is available. For the CI/CD process, we prefer GitHub Actions. Short, if we I want to give the short incident example and mitigation as well. The problem was payment service times out and users see the error. Mitigation in the design was circuit breaker tip, trips for the payment service calls and returns a user friendly fallback while queuing the retry. Rate limiter prevents the retransmission storm. Auto scaling kicks in for the payment service if the issue is in resource execution exhaustion. Alert and runbook notify on the call, and tracing helps diagnose which downstream call caused failure. At the last, I want to say that design for the common cause with edge caching and stateless services absorb spikes with queues and auto scaling. So, to protect system health with circuit breakers, bulk head, and strong observability, observability, while accepting eventual consistency for non-critical paths. Thank you.